In question 4, we have a particle projected with speed 10 from the foot of an inclined plane, which makes an angle of 30 with the horizontal. So find the range in cases where A, the angle which the line of projection makes with the horizontal is 75 and 60. Okay, let's read as two separate questions here. My horizontal, my line of projection, we have 10 meters a second, popular speed, and we have 30 with the horizontal. So in the first case, 75 would make this 45, and obviously 30 and 30 in the next case. So my initial velocity vector here, u cos A in the I direction plus u sine A in the j direction, is going to be 10 cos 45 in the I direction plus 10 sine 45 in the j direction. And 1 over root 2 is 40 cos and sine of 45, so 10 over root 2 can be written in a different format, plus 10 over root 2 in the j direction. We'll simplify it down at the end. So that's my initial, my accelerations. In the I direction, it's going to be minus g by the sine of whatever angle is in here, sine 30, and for j, minus g by the cos of whatever angle is in here. So sine of 30 is a half, so minus g over 2. Cos of 30 is root 3 over 2. Root 3 over 2g minus. So now we are asked for the range, so we need the time taken of flight. So when is s of y equal to 0? So when is ut plus a half at squared equal to 0? My initial in the y is 10 over root 2, this guy here, times t, minus a half, you want to do it over here, a half by root 3 over 2, it's going to be root 3 over 4, so minus root 3 g over 4 times t squared. Factor out your t, and you're going to get 10 over root 2 minus root 3 gt, it's a tongue twister, over 4 equals 0. So my initial time is equal to 0, and here we're going to get, well, it's a bit funny looking, so let's say 10 over root 2 equals root 3 gt over 4. Don't try and simplify it too quickly, there's no prizes for speed. 40 is equal to root 2 by root 3, which is root 6 gt, so t is equal to 40 over root 6 g. That's the time of flight. So now we need s of x. S of x at t is equal to 40 over root 6g. So s of x, we had 10 over root 2 as well up here. So s of x ut plus a half at squared is going to be 10 over root 2 times 40 over root 6g minus, we had g over 2, but just double check, minus g over 2, so that's minus a half by g over 2 by t squared, which is 1600 over 6g squared. Tidying this up, 400 over root 12g minus, well, 4 goes into 1600, makes it 400, 6 goes into 400, well, 2 goes into each of them, 200 over 3. And that's all I can do, the g and the squared. So it looks like I'm left with minus 200 over 3g. So let's try and tidy this up a bit. 400 over root 12, but that's 400 over root 4 root 3, which is 2. That's a 2, that will be 200 over root 3 times g minus 200 over 3g. If I get rid of the third here by multiplying top and bottom by root 3 over root 3, I'm going to get 200 root 3 over 3g minus 200 over 3g. So now I can factor out 200 over 3g to get root 3 minus 1. That's a nice tidy way of looking at the range when the angle is 75 degrees. Okay, back up to when it's 60. So everything else remains the same. So we have our accelerations. We have the angle of 45 is going to be different. So my initial velocity here. So u1 is going to be u cos, we have 45 the first time, we're going to have, just change it here, we're going to have a 30 in here this time. So u cos 30 in the I direction plus u sine 30 in the j direction. Cos of 30 is root 3 over 2. The velocity is still 10 plus 10 times a half in the j direction, so we're going to get 5 root 3 in the I direction plus 5 in the j direction. So we have the same accelerations, these two guys, and we can write out s of y. So we just follow the same procedure. So when is s of y going to be equal to 0? So displacement in the y direction, my ut plus a half at squared. You could try and skip a few steps and do this much quicker, but I think just keep it simple. 5 in the y direction times t minus a half times the acceleration in the y direction. This minus root 3 over 2. We have the minus in already, so root 3 over 2 times t squared minus this equal to 0, minus 5t minus root 3 t squared over 4 equal to 0. Factor out your t to get 5 minus root 3t over 4 equals 0. So this is my initial time is equal to 0, and here I'm going to get 5 is equal to root 3t over 4. So 20 cross multiplying divided by root 3 is the time taken to get there when the angle of projection is 30 degrees with the incline. So now filling this into your s of x. S of x at t is equal to 20 over root 3. So my ut plus a half at squared becomes, we have this 5 root 3 now in the I direction times t, which is 20 over root 3. Then we're going to have minus the half, bringing in the minus acceleration. Acceleration is g over 2 from up here times g over 2 times t squared, which is going to be 20 squared, 400 over root 3 squared, which is 3. So we're going to get 100 minus 2 2s are 4, it goes into 250 times. So we're going to get 100 minus 50g over 3. Does that look right? 50g over 3. Okay, I hope you're all seeing my mistake here. I left out my g, my g, my g. So the root 3 and the g on the bottom. The g, same, you got having to go back and make this whole video again, so it should be a 3g squared. Too many videos in one day, so that one cancels with that one. There's a g here, so it should be 100 over g minus 50 over 3g. And in my head I divided 400, this 20 squared is 400, so that should be double, that should be 100. So I'm left with 100 here. So 100 over g minus 100 over 3g times top and bottom by 3 to get 300 over g minus 100 over g. And eventually, with too many mistakes, if any of you got to the end of this video, congratulations, because it's more than 10 minutes long. But I think the answer is 200 over g.